Hey there, deep diver. You guys sent us a paper, and the title itself is wild.
Oh, yeah.
Auto-regressive next token predictors are universal learners.
Okay, right off the bat, that sounds like it's straight out of science fiction.
Yeah, we're diving into AI today, and we want to know if this paper's claim is true. Can we build machines that can learn? Like anything.
It's a question that's been around forever, like philosophers, computer scientists, everybody wants to know if we
Right.
can actually make a machine that can learn anything.
Yeah.
And this paper is kind of shaking things up a bit because they're saying that universal learning might be simpler than we thought.
Okay, so before we get too far, let's back up for a sec. What are auto-regressive next token predictors? Like in English, please.
Yeah, so you actually use these every day.
Oh.
Think about your phone, right? Like when it tries to guess the next word you're going to type, or
Mhm.
like those chat bots that are getting really good at sounding like a person,
Mhm.
that's all powered by next token predictors.
So it's like they're always trying to guess the next word in a sentence
Mm.
based on the words they've already seen.
Exactly. They're basically playing a really advanced game of fill in the blanks.
Okay.
But the crazy thing is,
Yeah.
this really simple idea of just predicting the next word. That might be how we build machines that can learn to do anything a computer can do.
Wait, hold on. How does guessing a word translate to, like, I don't know, composing a symphony or designing a skyscraper? How do you go from A to B there?
Well, that's where it gets really interesting, right? So the researchers, they use this analogy of something called a Turing machine.
Okay, Turing Machine.
Have you ever heard of a Turing machine?
It rings a bell, yeah, but I'm gonna need a little refresher. It sounds pretty technical.
It's actually a pretty simple idea.
Oh, thanks.
So picture this, right? You have this machine and it's got a long tape in front of it.
Okay.
And on this tape are symbols, right? And the machine, it can like read and write on the tape, and it does that by following a set of rules. That's basically it. That's a Turing machine. Think of it like a really, really simplified computer.
Okay, I'm with you so far. So we have our simplified computer. How does that connect to our word guessing AI?
So as simple as a Turing machine seems, it can actually, like, theoretically, do any calculation that any other computer can.
Really?
If you give it enough time and memory, of course.
Right.
So it's like the most powerful model of computation that we have in theory.
Mm.
And what this paper is saying is that they've proven, like mathematically proven, that even a simple model, but one that's trained on next token prediction, like our word guessing AI,
Right.
it could theoretically be just as powerful as a Turing machine.
So you're saying if we train this word guessing AI in the right way, it could learn to do anything a computer could do,
That's the incredible claim that this paper is making. Yeah.
even something complex like design a skyscraper.
That's what they're saying.
Wow. Okay.
And it all comes down to how it learns. This next token prediction and something they call chain of thought.
Chain of thought.
Mm-hmm.
Okay, now you've got me really intrigued. We're going to have to save that juicy detail for part 2.
Yeah, we'll get there.
We'll be right back after a quick break. Deep divers, so don't go anywhere. All right, so chain of thought. What is that, and how does it turn a word-guessing AI into, like, something that could design a skyscraper?
Yeah, so it's not as crazy as it sounds. Imagine instead of just like giving someone the answer to a math problem, you show them every single step involved. So
Right.
like they can see the thought process, right?
Oh, okay.
That's basically what chain of thought is. But for these AI models, we're giving them that inside look at how we reason through problems.
So instead of just saying, here's your skyscraper blueprint, we're showing the AI all the little calculations and design choices that got us to that final product.
Exactly. Like think about something like multiplication.
Okay.
It can actually be kind of tricky for AI, especially when you get to bigger numbers.
Mhm.
The paper actually gives this really cool example of a simple model that really struggled with multiplying 4-digit numbers.
Okay.
But then they started training it with chain of thought data.
Okay.
So basically, they were showing it all the steps involved in multiplication.
Right, like show your work, right.
Exactly.
I've-
And when they did that, something really amazing happened.
All right, you got to tell me, what happened? Did it suddenly turn into like a math genius or something?
Pretty much. This simpler model, just by being shown how to multiply step by step,
Yeah.
it was able to multiply 4-digit numbers correctly over 97% of the time.
Wow.
And get this, they compared this to a much larger language model.
Okay.
Think like the technology behind ChatGPT, right?
Hmm.
That larger model only got it right about 5% of the time.
Wow, that's a huge difference.
Yeah, it's a big deal.
So you're saying a simpler model, by being shown the steps, crushed this cutting-edge language model. That kind of goes against everything we think about AI, right? Like, bigger isn't always better.
It really makes you think twice about how these models learn, right?
Yeah.
And this is what I think is so cool about this whole chain of thought idea.
Uh,
It's like maybe, just maybe, the key to getting AI to learn at a much deeper level isn't about making them bigger or more complex,
okay.
but about how we teach them, about giving them the right kind of information.
So is this paper saying that we're about to have AI that can do our taxes and write the next best-selling novel just because we're showing them how to think step by step?
Well, hold on now. Let's not get ahead of ourselves. It's not quite that simple.
Right.
Like any scientific discovery, there's some nuances here, some limitations we got to consider. And the researchers point out a big one. They call it length complexity.
Length complexity. Okay, now I know there's a but coming. Tell me more. Okay, length complexity. Lay it on me. What's the catch?
Well, think of it this way. The more complex something is, the longer and more detailed those intermediate steps, that chain of thought needs to be.
Right.
Like teaching a machine to multiply, that's one thing, but teaching it to understand like human language and then create something new, like a whole novel,
Right.
that's going to need a way longer chain.
So it's like giving someone a grocery list versus explaining the entire plot of War and Peace,
Yeah.
right? You'd need a lot more paper for one than the other.
Exactly. That's length complexity in a nutshell. A simple email, maybe a short chain of thought does the trick, but a whole movie script with interesting characters and a plot that keeps you guessing, that might need a chain as long as, well, a novel itself.
So even if we show AI how to think step by step,
Mm-hmm.
there's a limit to how much thinking we can actually demonstrate, right?
Mm-hmm.
Especially for really, really complicated stuff.
Yeah, exactly. And that creates this really interesting problem. These simpler models, they could theoretically learn anything, but the harder the task, the harder we have to work to teach them. It's like this whole new way of thinking about what AI can and can't do.
This deep dive has been amazing. We're really only scratching the surface here, but what should our listeners take away from all this?
This paper is making a huge claim, and I think it's one we should pay attention to. Machines might be able to learn way more than we ever thought possible, but it's not just about making them bigger or fancier. It's about figuring out how they learn best and how we can teach them in a way that makes sense.
And this idea of length complexity, man, that really changes things up. It makes you wonder what the limits of teaching these machines really are. As we get better at this whole chain of thought thing, who knows what incredible stuff AI will be able to do? That's something that'll keep researchers busy for a long, long time, I'm sure.
Absolutely.
Thanks for coming on this mind-blowing journey with us, deep divers. It's been a wild ride.